Okay, I'm here to help you with your review. I won't take too long going over the entire review, but I do want to take some of these questions up in case you're not certain why the answer is the answer. So I'm looking at page 430 first, and we're going to take these multiple choice questions up. Which of the following is taken into account in estimating a person's body mass ratio? That's going to be all of these. Okay, so you might not have done enough reading on that. I'm not going to ask you this question, but I did want to take it up. So age, height, sex, all of those things are taken into account when you're looking at your BMR. Proteins are made up of long chains of smaller molecules called, this is something you absolutely have to know, so this is B amino acids. Vitamins A, D, and E, and K are fat soluble. What does this mean? I didn't spend any time doing that or talking to you about this, so here's 30 seconds. If the vitamin dissolves in fat, it is fat soluble. What does that mean for you? That if you want to absorb these guys, you have to have a fat with these things. So if you're having carrots with vitamin A, you need to make sure that you got a little bit of butter on the side or something, oil, okay? Because if not, it's not going to be soluble. It's just you're going to get rid of it. So we store these vitamins in our fat. On that side too, quick little explanation, these guys can be toxic in high amounts. So in other words, because you store them in your fat, you're not going to be peeing them out. And so they can build up in fat tissue. All right. So there's always that happy medium of what you're going to take and how much you're going to take in of these vitamins. So please, if you're having a healthy diet, don't worry that you're going to have a toxic reaction to vitamins. Okay. That's not what I'm saying. But if you take a lot of vitamins, you have to be really careful because these guys will store up in your fat. So what does that mean? It means they dissolve in fat. 4, which of the following shows the correct order of the main steps in human digestion? So again, because of a lack of time, I didn't go through this with you, but you do need to know that you ingest your food, okay, just in terms of life even. You ingest food, that means you take it in. Then you're going to digest it physically and chemically. Then you have to absorb it, okay, in the villi in the small intestine and the lacteal. And then you have to get rid of anything that you consider not useful. So egestion gets rid of waste products, okay? And waste is really just anything that you and I cannot digest and absorb. So the correct answer for that is C. So please do know that. What prevents food from entering the lungs from the esophagus? So we're looking for the epiglottis. This is the correct answer. Which of the following best describes pepsin's role in the stomach? Pepsin, okay, when you see that, think P for protein. So it's going to be a protein digesting enzyme. All right. Oops, sorry. Whoops, little technical failure there. Number 7. I'm just going to adjust this so that I know you can see it. In which section of the small intestine are most nutrients absorbed? So that's typically going to be the 3rd section, which is the ileum, okay? There's certainly absorption going on in the jejunum, but there's also a lot of chemical digestion there. So the ileum is our best answer. All right, and then number 9, your energy requirement is the same each day regardless of your physical activity. Absolutely false. Increase that physical activity, increase energy requirements. Your body needs 6 essential nutrients in order to stay healthy. Yes, absolutely true. Your digestive tract is actually much longer than your body. Yes, if you could take out that alimentary canal, it's actually very, very long, okay? Gastric juice is not a particularly strong acid. Incorrect, totally false. It has a pH rating of about a 2, so that's very strong. Most of the digestion of carbohydrates, proteins, and fats takes place in the stomach. No, not true. Most digestion will take place in the intestines because you've got chemical digestion going on there. So I would say the stomach is a second to the small intestine. Okay, it would come in second there. And then we move on. And I gave you, for the respiratory system, I gave you page 469, questions 1 to 7. So which of the following best describes the purpose of aerobic cellular respiration? Definitely to provide oxygen for body cells. Okay, it's not providing oxygen for lungs, although the lungs do have cells that require oxygen. It is not that, and it's not to provide energy. That's something different. That happens in the mitochondria. So we're looking at 1A is the correct answer. How is the majority of energy that is released in aerobic cellular respiration used? Okay, so you might be encouraged to say, okay, it is stored as ATP, but that's not actually true. So most of our energy is actually wasted as heat. So cellular respiration is about 41% efficient. So in other words, we've got another 59% that we're wasting. Okay, so most of the energy is released as heat, but a huge amount of energy is stored as ATP. Where does gas exchange take place in the human body? Gas exchange is going to be in the lungs and the body cells. So both, right? Alveoli and body cells. We don't exchange gases in our skin. Which of the following best describes the process of ventilation? So I've already circled this going into this. Oxygen moves into the lungs, true. Carbon dioxide moves out of the lungs, true. But ventilation is another way of saying breathing. So if you're ventilating, this is what you're doing. Okay, you're doing both. And this is not true. Which respiratory structure sequence is correct? So we start with the trachea. Okay, so every one of them is right there. And then we're going to go into the bronchi, the bronchioles, and the alveoli. So A is correct. During inhalation, the diaphragm contracts, causing the volume of the lungs to decrease. No, because when we're inhaling, we're taking in more breath. So a little bit of common sense here. You're inhaling, you're taking in more air. So volume of the lungs to increase. So B is the correct answer. And then lastly on this page, in the lungs, most of the oxygen taken in diffuses into the blood and binds to hemoglobin. So this is something you and I'm going to discuss with you next week when we get to the circulatory system. Okay, so you didn't really have a way of knowing that unless you did the reading, which I signed. So the correct answer is it binds to hemoglobin. All right, and hemoglobin is found in your red blood cells. All right, now that is going to be a question for another day. All right, so you don't have to worry about this because I'm going to test you on this in your circulation quiz. All right, so quick look here. Hopefully I can keep things quick for you because I know it's probably really tedious to listen to my answers all for like 20 minutes. So study your nutrients, know the building blocks, uses, and sources. All right, so building blocks for sure. I'm going to ask you what makes up fat, and you're going to pick glycerol and fatty acids. Okay, uses and sources definitely could come up, but I'm telling you, this is what I'm going to focus on. Number 5, be able to label a diagram of the digestive system. So you're going to have hundreds at your fingertips, okay, literally. Can you, if I give you a piece of the digestive system, can you pick out the pancreas from the gallbladder, that kind of thing? So that's what I'm going to do with you. So in the past, I would have given them a whole bunch of diagrams, okay? And that would be our communication section of our test, where you'd get the digestive system, the circulatory system, which is the heart, and the respiratory system. I can't test you in that way this semester. So what I'm thinking right now, and I'm going to be setting off to make the quiz after I take this up with you, I'm thinking I'm going to give you organs, okay? And you're going to identify them, all right? So we're going to go with that. Be able to identify organs of the digestive system. You have, today you have the weekend also, okay, to look those up. I'm not going to make things hard. I'm going to pick the best diagrams I can find, okay? The ones that are the most obvious. I'm not out to make things hard for you. What are the functions of each of the parts of the digestive system? Include accessory organs. So you're going to have to go through the mouth, the pharynx, just at a loss for a second here, the mouth, the pharynx, and then the esophagus, okay? The stomach, what happens there? What happens in the small intestine in each of those 3 sections? So what happens in the duodenum, the jejunum, and the ileum? What happens in the large intestine, okay? And then you have to also include accessory organs. So you have to tell me what the function of the pancreas is, the function of the liver, and the function of the gallbladder. Okay, and I did mention to you that some people consider salivary glands accessory organs. So there's not much I can do for you now because I'm not going to reteach this. All you need to do at this point, because you guys have the advantage, you can replay the video where I taught you all about this. Okay, so normally in a semester I have to go over everything again because they can't keep replaying what I've done. List the digestive enzymes with their functions. So again, please look at that up. I'm certainly going to be asking you about that because this is really new for 3U. So this is something that I don't want you to leave not knowing. So know what lipase does, know what pepsin does, know what all those enzymes do that we went through. Be able to distinguish between the following terms. So breathing is a physical act where your lungs and your diaphragm and your intercostal muscles are bringing air into the lungs and then expelling air. Cellular respiration is something that happens at the level of an organelle, so not even in a cell, okay? This is happening in the mitochondria. And so endosymbiosis, right, from evolution, this is happening in the mitochondria. And so this is your C6H12O6, so some kind of a food source, energy source. You absolutely require 6 molecules of oxygen. And what is that going to get converted into? Waste gas, carbon dioxide, and you're going to make water. Okay? But what's the whole point of this? Is that you're going to make, and I'm not going to lie to you guys, you're going to make about 36 ATP. If I get to see you again next year, which would honestly be a pleasure, I have to tell you guys, you've been doing so amazing keeping up. Okay, you're very strong students, very good students, and I know that you can cheat easily, but I also know you from the very first beginning of the semester, and I know that you're strong kids, okay? So if you're thinking about taking bio, go for it. So what I'm telling you is that this here is not set in stone. So in all honesty, just a little preview, we make 30 to 38 ATP, depending on the different type of cell. That's for you stuff, so I will not ask you that. So this is cellular respiration. Again, what's the common theme? The air has oxygen. Cellular respiration requires oxygen. And what is gas exchange? It's the exchange of carbon dioxide and oxygen, depending whether you're looking at the alveoli to the blood cells and the blood to the body cells. Okay, that's going to change itself up a little bit. How are they related to each other? The respiratory system takes care of all of this. Okay. Be able to label a diagram of the respiratory system. So once again, if I give you a section of the respiratory system, can you label it as a trachea, a bronchial, alveoli, that kind of thing? What path would air take into and out of the lungs from the nostrils and the mouth? So you're going to, I didn't take this up with you, you're going to go nose or mouth, okay, to the pharynx, to the we can say like the trachea, but I'm going to go with larynx. So this should, forget that, that's not a T. We're going to say larynx. All right, larynx, and then we're going to have the epiglottis there, but air doesn't go through the epiglottis, so don't mention it because it's not physically going through it. I'm going to continue here in the flow chart. Larynx to trachea, okay, to bronchi. You have 2 of them. To bronchioles, to lungs, and in those lungs we really need to mention the alveoli. Okay, so we could actually make this last, or you can make it a bracket, okay, because these guys are super important. All right, list the functions of each part of the respiratory system. Okay, so I've already gone through that with you in some detail many times before. And then what are cilia? So I'm not going to test you on 13 because I wasn't sure if I was going to have time to even go through it this semester. I just want to say one thing, okay? Just one thing, sorry. You have an expiratory reserve volume. So just so that you know, your lungs will not empty out. You cannot force air to completely empty your lung. The only way you can do that, you can't force it out. The only way you can lose all air in your lung is if your lung collapses, and that's a very rare thing to happen. So I just wanted to make note of that because usually when I'm teaching this lesson, we actually breathe air in, then we breathe extra air in because we have an inspiratory reserve volume. So this is like regular breath. This is taking extra air in. This is seeing how much you can breathe out, but you can't ever fully empty your lungs, and that's what I wanted to tell you, okay? All right, because you have this residual volume, and that's why you can't empty your lungs, okay? This is like you can breathe out a little bit more. You can try and force air out of your lungs, but you can't completely collapse your lung because you have a residual volume, okay? So just a little aside there. What are cilia? They are hair-like structures that are found in the respiratory system. They're located all over the respiratory system, but particularly in the bronchi and the bronchioles, okay? That's where you're going to find them. What functions do they serve? They serve the function of sweeping out contaminants. Anything that could harm your lungs is swept out, okay? And just as a note, I don't think you guys are smokers, but maybe 10 years ago, I know that I had some smokers. Hopefully kids are getting smart and realizing that's bad. And I think they are. But if you are a smoker, if you know somebody that's a smoker, smoking kills bronchial cilia, okay? So it kills it off. And so that's where you get that smoker's cough. Okay, so what's happening is they don't have cilia to sweep out those contaminants. So those contaminants are getting further and further into the lung. The lung does turn black, and it's getting contaminated. Okay, good thing is if you stop smoking, the cilia will grow back. The lung will clean itself out. Okay, so you guys do as best as you can on the quiz on Monday, and I will give you information on the quiz ASAP as soon as I write it.